Right, so this is on page 106. I'm working number 19. It says, for these problems right here, we're supposed to consider a rectangle that has a perimeter of 120. So I'm going to start by getting the right thing. Okay, so I'm going to start by drawing a rectangle. And you remember from geometry what a rectangle is. Draw one a little bit better than mine. But anyway, so here's a rectangle. We know that we can use, it talks about the dimensions of a rectangle. We know that a rectangle usually has two measurements. This measurement right here, we're going to call the length. If this is, whatever measurement this is, that's the length. This one right here will be the same as this one. And this length right here we'll call W. And so this length over here will be the same length as those. That's one of the characteristics of being a rectangle, is that opposite sides are congruent. Also, we know that we have 90-degree angles. Okay, so what else do we know about this? The perimeter of this rectangle is 120. All right, so think back to geometry. What is the perimeter? The perimeter is the sum of all the sides. So if I add the length plus the width plus the length plus the width, then I know that that is going to be 120. The perimeter is 120. I'm going to do some algebra right here. I'm going to combine like terms. 2 length plus 2w. Why? Because I can, and that makes my equation a little bit better. I also am going to show you that this equation is also the same. Now, algebraically, what did I just do? I just factored out a GCF, the 2 factored out. Geometrically, what did I do? Well, this is saying that add these 2 lengths together and add those 2 widths together, and you'll get 120. And this is saying add the length and the width, and then add a second length and the width, and you'll still equal 120. Well, algebraically, I want to divide both sides by 2, and that should make sense to you geometrically. If all the way around is 120, then halfway around, one length and one width should be 60. Now you're going to understand why I did this in just a second. Because for problem number 19, it says write a function, and they tell me what to call the function that represents the area. Well, let's go back to geometry. Area for a rectangle is length times width. And so to do what this says, we're simply going to take the A out, and we're going to call this B of L. Okay, so we're almost done, except the problem is that because of this function rule right here, this says that my only variable should be L's only. So what's wrong with this problem? It's only supposed to have L's in it. So what do we need to do? We need to get rid of that W. So this function rule is telling me in my equation I can only have L's. Well, I have to multiply the length times the width. Well, there's this relationship over here between the length and the width. So if I do my algebra and subtract L from both sides, I'm going to get 60 minus L is equal to W. Hopefully now you're kind of getting a bright idea how I can alter this equation a little bit. I am going to still say length times, but we learned with substitution not too long ago that if I have a width, and over here I know what the width is equal to, I can take this and substitute it in for the W. So this is going to be 60 minus L. So I now have an equation that represents the area, and it only has L's in it. The length times the width represented as 60 minus the length. This form right here is the factored form. And the reason it's the factored form is because these are the factors. These are the two things that you multiply together. And if we go ahead and multiply that together, then we will get 60L minus L times L is L squared. Okay, so I have this right here is the standard form. Okay, and problem number 19 says, doesn't tell me how, but problem number 19 says, write a function B of L that represents the area of the rectangle with length L. So that is the answer to number 19. Number 20 says they want us to graph it.